Welcome everybody. My name is Maarten Breddels. On my right, your left, is Sylvain Corlay. And we're going to talk about Jupyter widgets. So Sylvain is founder of QuantStack, member of the Jupyter steering committee, quite an active Jupyter developer. I'm a former astronomer, now freelancer, consultant, working a lot with QuantStack. Also a widget developer. Both of us are widget developers. And I want to give a shout out to Jason Grout, who's over there, who's been not only a really important maintainer of the IPy and Jupyter widget system, but also a really important member of the community. And you can find Sylvain and me online on GitHub, Twitter, at these handles. So on the agenda, so I want to give a bit of an introduction to the Jupyter widgets by giving you an overview of some of the libraries that are out there, so to get a feeling of what's possible. And then Sylvain will show you with different languages and go a bit more into depth on some of these libraries. And then I'll take over and show some crazy examples of what you can do with widgets. And then at last, something we're really enthusiastic about. So Sylvain is going to demo how you can use Jupyter widgets outside of the Jupyter notebook with a live kernel. So this is my lucky slide. So we're going to do live demos, but after this slide, they always work. So we'll see. Can everybody read this? Yeah, great. So IPy widget is like the Python binding to Jupyter widgets. So let's import this. Let's get rid of this. So I'm going to create a slider. And like anything in the Jupyter notebook, you can print it out. So I'll print out the slider. And instead of like a number or a NumPy array, you get like a GUI component. So what happens if I print it out twice? I see the same thing, and they're synchronized. So how does this work? What's the model behind this? So if you create a widget, in this case in the Python kernel, so I create this slider, I create a widget in the kernel, and at the same time it creates a widget at the front end. And each time I print out a slider, it will create a view. So in this case I have two views. If I change the view, it will something in the view, it will update the model, synchronize it to all the views, and synchronize it to the kernel. And that's one of the key points, the bidirectional communication. So that means so now the value is 8 on the slider, I can read it off from the Python side and the other way around. So if I set it, it will change the slider. So another really powerful feature of the IPy widgets is linking. So I create a text widget, and I say link the text value to the slider value. So if I now change the text value, it also updates the slider. If I programmatically change the text value, it also updates. So they all sync together. It's a really convenient feature. One line and you link two things together. Another thing is you can observe changes. So you can observe a change of one of the, like in this case, I observe if there's a change in the value of the slider, I execute this function which will set the style, the handle color of the slider. So let's try this out. So now I'm changing it in the front end. It will sync it to the kernel. That will trigger a callback that will change the property in the kernel that will be synced back to the front end. But all of this is like done for you. So this is like GUI elements, but it's more than a GUI element. It's a framework for bidirectional communication between the front end, so the browser, and your kernel, which in this case is Python, but it could be Java, Clojure, C++, or even R. So it's not just GUI elements. And not every widget needs to have a graphical representation. We'll see some of that in vickiplot. And you can think of it as being a higher level framework to build things like GUIs, visualization, etc. And to demonstrate that, I'm just going to show you the basics of some of the more popular packages. So one of them is vickiplot. Sylvain will show more on this. So it has a matplotlib API, but instead of having an image, you now have an interactive visualization. And with any property, I can change them, and it will update it. Without reproducing the whole plot, it will just sync it to the front end. So that was biqplot. Since version 3.0, Plotly also adopted the Jupyter widgets. So it works almost like the same. You create a plot, and afterwards you change the data, it gets synchronized to the server. So it's all like one framework. They all work quite similar. But there are also different libraries like completely different, like IPy Leaflet gives you like an interactive map that you can interact with, and also Sylvain will say more about this. And this sidecar widget, which is a really small widget library, but really useful. It will give you, and it's Jupyter Lab only, so a good reason to switch. And you get something on the side, and you can put anything in there, like print, put a slider in there. So this is the slider that I created above, and put this in here. We have 3D plotting. IPy volume, so I can put this on the side. So instead of having to scroll up and down, I can just have this on the side. And let me do a selection here. So I'm going to do a 3D selection. So I selected these, and now I can take a look at what the indices are of this, what I selected. Like biqplot, everything's animated. So if I change the data, you see what's happening. Really useful. So maybe you don't need 3D plotting, but something more complex. Then you can use Py3.js, which gives you way more flexibility, although it's a bit more work to set up, and give you like any 3D scene you want. You can make it as complex as possible. IPy Sheet, really useful for making spreadsheets, and each cell is a widget. So a cell by itself is not like, it doesn't have a visual representation, it refers to the sheet itself. And because it's an IPy widget, you can link it to one of the existing widgets. So typing is difficult. And it will sync this to this cell. A library that's like completely different, IPy WebRTC, makes use of the WebRTC API and the media stream API, giving you the opportunity to work with video streams, capture the images, and all of this is synchronized back to the kernel, so you have programmatic access to the captured image or download it. You can make video recordings, and not just of video things, but also, so let me start a recording. I can record, like if I want to do something fancy, show it to a colleague. I can record, make this recording, and just quickly download it and send it to someone, or programmatic access. Everything's, thank you. And really this programmatic access is really important, so you can like really make scripts and automate things. So the key messages here is that we have a variety of widgets. So different functionality from visualization, GUI elements, media streams. We have also data widgets, but they're all in this common framework, Jupyter widgets, so they really play nice together. And this bidirectional communication is a key feature. Like anything you change in the front end can be synchronized to the kernel, so you have this two-way communication. And I think also a different way of thinking about this is that you can now leverage the browser from your favorite language. So I'm now mixing Python, I'm now using Python, but I can use the full browser to it, which is a really powerful platform. Okay, so this is a bit of an overview of the libraries. So now I'm going to give the floor to Sylvain, who's going to give a slightly more in-depth discussion on some of the libraries and show how you can use it with different languages.
Thank you, Maarten. Hi. I'm going to dive a bit deeper into two popular plotting libraries built upon Jupyter Interactive Widgets. And the first one is biqplot. So what biqplot is a 2D plotting library built upon the Jupyter Widgets framework and implementing the constructs of the grammar of graphics and using D3.js. It was originally authored by a quant team at Bloomberg and released as an open source package a couple of years back while a lot of the authors were still at Bloomberg. I'm going to run some boilerplate to generate some data. And so bikiplot offers a matplotlib-like API called piplot that allows you to call like high-level routines to create charts. So for example, you can just call plot on XY, and that'll give you like this sort of interactive plot, unlike matplotlib. We have similar routines to piplot for scatter plots, histograms. We know that pie charts are a bit controversial in this community, but we allow pie charts, and if you really like them, you can make pie charts as well with wikiplot, or heat map and whatnot, even maps. So now this was about the high-level piplot API, but you can also compose your own visualization using the internal object model of bikiplot. And what's really special about it is that every single component of a figure is itself a widget that is an object synchronized between the front end and the back end. So I can create a few scales, create a figure, put something on the figure, and eventually get a chart, right? If I change the Y attribute of a line chart, I'm going to see it reflected visually, right? And this goes for pretty much anything. For example, if I create a scatter plot using scales and display some axes and grid lines, I can change the data, change the styling of the markers, set up a different minimum for the range of the X scale and see it reflected visually in the figure and all the figures using that scale. Set it back to none and have again the range decomputed based on the data. Or even interactively set up labels, titles, and whatnot. Also, scales are really at the center of the design of bikiplot. So what they are is they represent a mapping between data and a visual quantity, be it a color, a number of pixels, a size for a marker. So for example, in this visualization, I am displaying two scatter plots that have very different orders of magnitude for X and are about the same, have about the same values for Y. And I'm using two different X scales, but the same Y scale, right? If I change the data for one of the scatter plots, both charts that are using the Y scale are going to reflect that change. So now you can build complex visualization, reusing scales, reusing color scales, and everything is going to be linked together in a consistent fashion. Also, just like sliders allow for bidirectional communication, bikiplot figures and other Jupyter interactive widgets can be used to take the user's input. So in this example, I'm using an interval selector to select an interval in the front end. I can look at what has been selected. Here, I'm just counting the number of selected points, and this gets updated as I move the mouse and move the selector. This interval selector is actually interesting because the horizontal position of the mouse controls the center position of the interval. If I move the mouse up, it widens. So you don't have to redraw the interval selector every time you want to make it wider. It's really easy, just controlled by the position of the mouse. Or if you prefer a vertical interval selector, that is a brush selector, you can also do that and interactively change the way you select, or even use lassos and whatnot. We have a broad variety of interactions. One is a hand draw. If you have some complicated model that takes a function as an input, and you would like to explore the behavior of that model and for arbitrary functions, instead of trying it with linear components and signs, you can just draw it, right? What did I just do? Inspector. Yeah. And see it reflected in the backend. So here, for example, if I change the beginning of the time series, I'll see it change in the label below. You can also move points around and see the data be propagated in the backend and trigger some computation. So in this case, my model is computing the average of the Y values of the points. Whenever I move a point, the Y values should update. And you can do this for pretty much anything. So I just wanted to show you a more complex example that could be interesting for people in the educational context, which is a visualization of how Fourier series work. So it is so essentially it's a horizontal box with two charts, one corresponding to the Fourier coefficients of a Fourier series, and the other one is going to show the corresponding sine series. So that really displays how easy it is to actually have and produce interactive dashboards that take the user input in figures. We've used vickiplot to produce fairly complicated applications. This one here is a recreation of the Wealth of Nations visualization that is an animated bubble chart of all the countries in the world. The X coordinate corresponds to the income per capita, and the Y coordinate is the life expectancy of each country. So I can move it with a slider, animate. As I hover on a country, I'll see some metadata on that country, the name and the current life expectancy. And this was something you could produce with vickiplot. This is something you can produce with vickiplot with maybe 100 lines of code. Another plotting library, another package that I wanted to talk about is Leaflet. And just like vickiplot is a bridge between Jupyter and D3.js, Leaflet is a bridge between Jupyter and the Leaflet.js library. It's also open source, MIT licensed, and it's now a core Jupyter package. So you can just declare a map with a certain center and zoom level and display it inline. You'll be able to interact it very easily. But just like vickiplot, every single thing that you can put on the map is a widget, and you can update it, change it, and see it reflected. So let's add like some other layer, tile layer that's nicer. Show the same map in a sidecar widget. And now I'm going to load some GeoJSON dataset, do some messaging of the data, and put it in the map. And there you go. So you can basically put scatters, GeoJSON datasets, pretty much anything, even draw, measure things on the map using Leaflet. Another example that I think is really pretty is the fact that we enabled a number of Leaflet.js plugins in Leaflet, including the Leaflet Velocity plugin that allows you to display stream data on a map. So I think that one could be really interesting for people working in climate science because you can directly display an X-ray data set on the top of a Leaflet map, like in one line of code. So that was for Leaflet. All right, well, one of the main strengths of the Jupyter ecosystem is that more than a single implementation of an application, Jupyter is actually a collection of protocols and standard file formats that you can reuse and implement back and forth. There are multiple frontends to Jupyter. Some are desktop environments, others are web-based. You can also, one of the extension points to Jupyter, and that is the most popular, is the fact that you can create language backends, kernels for Project Jupyter. And I wanted to talk briefly about XEUS, and what XEUS is a modern C++ implementation of the Jupyter kernel protocol. It's not a kernel itself, it is a tool to author kernels easily for a target language. There has been a number of languages that have used XEUS to make kernels, like there is an R kernel called Juniper, and there is a C++ kernel called XEUS Cling built based on the Cling interpreter from CERN. So let's play with the C++ kernel. You can hash include iostream and std cout something, cr, throw a runtime error. If you omit the last semicolon, you'll see the last value of it. And I hope you appreciate that this is compiled code that I'm compiling incrementally along the notebook, right? You can also use a rich display mechanism of Jupyter, which is also one of these standards upon which that anyone can implement. So in this case, I created a very simple image class that all it does is loading an image file into a buffer and overrode the MIME bundle wrapper function, and that is picked up through argument-dependent lookup. When you create an instance of image, like here it's Mary Curie, and display Mary inline, you'll see the actual image displayed in the Jupyter notebook. So then we decided to go even crazier and implement a C++ backend to something else that is fully specified and for which we have a specified protocol that is the Jupyter interactive widgets. So XWidgets is a C++ implementation of the Jupyter widgets protocol. So you can create a slider widget, display it, change the value, see the value that was changed in the front end, change some properties. You can reuse an operator chaining syntax to mimic keyword arguments so that you can initialize widget attributes out of order. And here's a quick example of a button widget that counts the number of clicks, right? So C++ has never been that simple. And we went ahead and implemented other backends to other widget libraries. So we've seen IPy Leaflet, vickiplot, IPy volume, and so we are building up the stack. And now we have xplot, xleaflet, xvolume, x3js, xWebRTC even. And well, if you just want to do interactive GIS visualization in a C++ notebook, there you go, including computation in the backend and everything, which is not something C++ developers usually do. We're not the only people doing that kind of work. We really wanted to give a shout out to the Beaker X team at 2 Sigma, Scott Drafts, who led the Beaker X project, put together a collection of kernels and extensions to the Jupyter kernel interactive computing environments and wrote backends for most of the languages of the Java ecosystem, such as Groovy, Scala, Clojure, Kotlin. And that notebook here is a Clojure notebook that allows you to interact with Jupyter widgets, register to change events, create sliders, and bind widgets with each other. And they also have backends for Py3.js and other widget libraries.
So what I want to do now is to give a bit of a crazy example of what you can do, which I'm not sure if it's really practical, but it's a fun example of how powerful widgets can be. So one of the things that the IPy WebRTC package does is to give you access to WebRTC, which is basically pushed by Google to allow you to do video conferencing in the browser. So let's set up a chat room, which doesn't work. My lucky slide doesn't work, I guess. Let's go save. And okay. Oh, hi there. So what you're seeing here, that is Maarten sitting there. He helped me with the latest release of, he's sitting over there. Raise your hand, yeah. With the new release of IPy WebRTC, and he created xWebRTC, so you can have, maybe he's using C++ kernel, I don't know. But what I want is, he wrote an edge detection algorithm. So what I want to ask him is to run an edge detection algorithm for me on this video. So what I'm going to do now is I'm going to join the chat again, but now instead of using the camera stream, I'm using this video. So let me go up here. So this is me, this is Maarten, this is the video that I just added to this chat room. And now he's setting up his algorithm and running edge detection software on this stream and streaming it back. And this stream that I'm sending is now a video, but it can be a camera stream, it can be anything, it can be a 3D visualization. So this, just to illustrate how powerful this platform is. So it's not just video conferencing, because we're in a Jupyter system, in the notebook, we can send it anything. Okay, thank you. So let me close that. So I want to give you some advanced examples of, let me see how we're doing. Yeah, of IPy volume. to show how mature the Jupyter widgets are becoming and how powerful they're becoming, especially because 3D visualization is often an issue. So what I'm doing here now is instead of just doing a scatter plot, I can give it a two-dimensional array where the first dimension is time. And I think, yeah, I'm going to use the light theme. So what you're seeing here, this is simulation. I won't go into the details, but simulation in time. And I can change like the keyframe. But because everything's interpolated with a really coarse keyframing, I can get a pretty nice result. And these elements, so the slider again and this play widget, they come from stock like IPy widget. So I didn't develop that. So that's also the advantage. Like you can really reuse the existing components. And with this, you can really create like nice animations that look pretty smooth. So again, using IPy widgets, I connect a toggle button to what the marker is, so I can quickly change between arrow or sphere. One of the killer features, which is Cataplot. And it's not just Cataplot, so if you have a Google Cardboard, you can run this on your phone and do it in like VR. So if you're interested in cats in VR, then take a look at IPy volume. Maybe you don't have a Google Cardboard, but you may have a full dome display at home. Someone has this? Sure, we support this as well. We have one in our town, so I had to support this to make this possible. Or if you want to make like 360 degree videos on YouTube, they work with cats. But I think this is more scientifically useful. Okay, let me stop this. So the next release of IPy volume is coming soon, and one of the key features is more 3JS integration, which is more of a technical thing, but gives you a lot of flexibility to control things, and multi-volume rendering. So let me demonstrate this. Let me do this. So what you're seeing here is a volume rendering of a scan of a human head, and which is quite common. I mean, most serious packages have this, but the option to be able to have two volumes on top of each other, or even like partially overlapping, or not like fully, that's really like a big challenge. But that's going to be supported in the next version of IPy volume. So you can really mix multiple volumes in one rendering. The reason for this is that I'm doing this for the Glue project. So there, you can Google it. It's a multi-dimensional linked data exploration tool written in Qt, and they want to go to the Jupyter system as well. And let me give this some nice defaults and make this a little bit smaller. So let's say you have a 3D cube here and you want to make a lasso selection. So I'm interested in this. So you have now, and the defaults aren't so good yet, I'm working on that. So you can now do like complex interaction in 3D, and that's really making use of this multi-volume rendering. So this is really becoming a mature platform to build your applications in with 2D and 3D visualization. So at last, I want to give the floor again to Sylvain. He's going to talk about the project we're really excited about. So, please.
Thank you. So what people have been telling us about widgets so far is, well, they love using them. They love writing things with it and authoring data visualization. But what they would really like to do is be able to take these visualization and share it with other people. The management that doesn't know how to run a notebook or install an environment. How do I use Jupyter widgets outside of Jupyter Lab or the authoring environment, right? So we already had some options for that. We can already embed Jupyter widgets statically in web pages, blogs, in Sphinx documentation, but most of these are actually missing the possibility to interact with the computing backend, and that removes a lot of the features that we support in IPy widgets. There is another project that is just coming up by Minrag and Kelly called Phoebe Lab, which is allows you to have a single cell embedded into a Jupyter Notebook, and where you can that supports widgets and allows you to interact with a binder backend. But we really want to support that idea of putting together an application in the Jupyter Notebook and then bundling this into something you can ship to someone else. And this is a direction in which we will be going this year. And as a prototype or demo for this, we wanted to show you a command line utility called Voila. And what Voila is it's just that one-line utility that allows you to serve a directory containing notebooks, and what it will do when you try displaying a notebook using that Tornado app. In the backend, the notebook code will be executed with the kernel that is to be used. The kernel will stay alive for the user, and you will be rendered. You will see the HTML rendered notebook displayed in the browser. So yeah, Voila is already running.
It's running. We start it to make sure. Yeah.
Is this you? All right. So Voila is listening on port 8666. And there you go. We actually used Voila to display the Wealth of Nations notebook example. And as you can see, it's live. You have all of the code running in the backend. And if there is a complex model running and preparing the chart, you can interact with it in the Jupyter Notebook. So Voila is not something you can find online yet. This is a prototype, and we are going to push it forward in the coming weeks and months. So as a summary, so widgets are a diverse ecosystem. You have widgets for visualization, GUI building, data, 3D visualization, media streaming. We focus a lot on bidirectional communication, meaning that we like to offer a lot of ways to take input from the user. It's also a foundational framework upon which you can build anything. So if you have a JavaScript library that you would like to bring to the Jupyter ecosystem, it's fairly easy to make a widget for it. And you will benefit from the network effect that from being a widget, you will have it work and work with all the other widget libraries out there that we have demoed today. And it will be very easy to make a backend for other kernels than just Python. So because most of the code is frontend, and the backend tends to be really thin and have very little logic implemented. Well, thank you. We'll be taking questions now.
So I'm a custom widgets developer. I use IPy widgets. And in the moving over to Jupyter Lab, one of the biggest things to be able to do is have that widget out and move over to that side view like we did in Sidecar. I guess my question is Sidecar, is that the best development practice moving forward? Or I mean, because when you develop a widget, you don't have any, for good reason, you don't have any reference into the actual Jupyter Lab app instance, right? So what's the best way to get it to move over to Sidecar?
So I would say that widgets, what they are about is a means to communicate between the frontend and the kernel. And if the frontend happens to be Jupyter Lab, you can use the Jupyter Lab interfaces. And Sidecar is the first example of a widget doing exactly that. It assumes that you're running in Jupyter Lab and that Jupyter Lab is available on the page. And it uses the Jupyter Lab APIs to create menus and tabs on the right-hand side. And you could be doing anything bad as well. So it's so Sidecar does that. You can make use of the Jupyter Lab components from within the widget.
So then I guess not to get too technical, but when you're offering an IPy widget, you don't have access to the Jupyter Lab API. Is that I mean, I could be missing something.
As a widget author, in your JavaScript code for your widget, you can use the Jupyter Lab APIs.
Well, so from
Yeah, from the Jupyter widgets frontend code in JavaScript you can. So you can make a custom widget that will expose some of these Jupyter Lab APIs to Python.
So it's basically, you can think of it as being a special notebook server where it's using MB-convert to render the HTML, but keeping the kernel alive. So it's just like in the notebook, keeps the kernel alive. The difference, I would say, to summarize it, between the notebook is it doesn't allow arbitrary code execution, and it doesn't send the code to the client. So it only sends the output to the browser, to the client, and it does not allow for arbitrary code execution, just showing the output and allowing you to communicate using the widget, for instance. So the server is running the kernel.
Can you say something about like the scalability of IPy volume? So like, what if I put in like a million points? You know, like what sort of scale of data set can it visualize?
Let's just try it out. So how much do you want? 1 million? Yeah. Yeah, I can make it a bit faster because this is using spheres, so they have quite some. Wait, let me do this here. Can I do this? Marker is, so if you use, this is less polygons, so this is much faster. So, and I should save this. So this is S. So maybe it's a bit too big. So maybe this, no, 1. Yeah, so it's still like all the animations are smooth. So I would say up to 1 million on a high end. But I actually built IPy volume to be able to show data sets up to 1 billion. But instead of showing the individual points, you calculate like a 3D cube, say with the statistics, like 3D bin histogram, and then use the volume rendering for that. So that's why the name is there, IPy volume, because I needed volume rendering for really large data sets. So if you're interested in that, I can show you afterwards. Yeah.
Thank you.
Thank you. I will also be at the sprints tomorrow, so if you have questions, feel free to ask tomorrow.